This video is over section 9.2, exponential functions. Let's start with some definitions. So for exponential function, let b be a constant real number. Such that b is greater than 0, or sorry, yeah, b is greater than 0, and b is not equal to 1. Then for any real number x, a function of the form f of x is equal to b to the x is called an exponential function. And we'll say an exponential function of base b. So when we're talking about exponentials, b would be the base. All right, so there's two types of exponential functions. There's an exponential growth and an exponential decay. For an exponential growth, if b is greater than 1, then it is an exponential growth. So when we have f of x equals b to the x, and that b is greater than 1, and remember up here, we assumed that b had to be greater than 0. So if it's also greater than 1, then we have an exponential growth. I'll just put then growth. Okay, for decay, if b is between 0 and 1, so it's still greater than 0, then it's a decay. And same thing, f of x equals b to the x, but this time that b is a fraction of 1, so like 1/2, 1/3, 0.25, things like that. Okay, when we graph these two functions, I think we'll see better what's going on. So f of x equals 3 to the x. Just to start, I'm going to make a table of values just so we can kind of see what's going on. I'm going to start with 0. And if I have 3 to the 0, that's equal to 1. So my first dot is going to be 0, 1. If I plug in a 1, that's 3 to the first power, which would just be 3. So my next dot is going to be 1, 3. If I plug in a 2, that would be 3 squared. So the next point would be 9. So 2, 9 is going to be off the grid. So I'll just put a dot right there. I won't go any further because it's going to go way off the grid. I do want to go backwards 1. So if I plug in a negative 1, that's going to be 3 to the negative 1, which is 1/3. So that point would be negative 1, 1/3. And I have enough points to kind of see this curve. And here, notice that we have b is equal to 3. And so since 3 is greater than 0, this is an exponential growth. And from the graph, you can also see left to right, the graph is growing. Awesome. Okay, so we're going to do the same thing on the next one. Let's start off with the t-chart. The fraction makes it a little difficult, but shouldn't be too bad. I always like to start with 0. So if I plug in 0, that's 1/5 to the 0 power, which is just 1. So 0, 1. If I plug in a 1, that's 1/5 to the 1, which is just 1/5. If I plug in a 2, 1/5 squared would be 1/25. So that's like basically 0. Like it's very, very close to 0. So I do want to go backwards a couple spots just so we can see the full picture. So if I plug in negative 1, 1/5 to the negative 1 is 5. So negative 1, 5. If I plug in a negative 2, I'm going to have 1/5, 1/5 to the negative 2, which would be positive 25. And that's like way off the grid. So what we're going to see is it's going to go really steep here and then drop. That is so crooked, sorry. Drop almost to 0, but never cross. Okay, so for this one, we have b for this one is 1/5. Because b is between 0 and 1, this is an exponential decay. And you can see left to right, the graph is decreasing. Awesome. So I'm going to use a different color to kind of talk about slang. So here, this is creating a multiply by 3 pattern. And this one is creating a divide by 5 pattern. Or you can think about it in the same way, multiply by 1/5. Multiplying by 1/5 and dividing by 5 is the same thing. So kind of what I'm saying is like down the page, we're dividing by 5 as we go. And then same here, down the table, we're multiplying by 3. Awesome. Okay, so for this word problem, it says suppose that $40,000 is invested at 6% interest for 10 years under the following compound options, and we're going to complete the table. So we are going to use the formula. It's in the textbook, and then I'll give it to you here. A equals P times 1 plus R over N to the NT. Okay, and what all of this stands for is P is principal, so I'll use a different color here. P is the principal amount, so starting point. R is going to be the rate as a decimal. T is years. And then notice here there's 2 n's. And n factors in like how much it's compounded. So let me think of a good way to say that. Number of times compounded. If I think of a better way, I'll come and fix that. But for now, that's probably what I would say. All right, so we have 40. I'm going to make my pen a little smaller because this is a small table. We have $40,000. We have 6% interest. So P is 40,000. My R is 0.06. We need to make that a decimal. 10 years would be time. Okay, and then the N is going to change based on which row we're on. Okay, so if we are considering interest annually, that means my N is going to equal 1. And so the formula that I'm going to use for that would be A equals 40,000 times 1 plus 0.06 over 1. And then my exponent is going to be 1 times 10, because 10 years. I'll write outside the table for this. I probably should have made a separate column. Okay, I'm going to type it in my calculator very carefully. And I'm going to get, this is money, so this would be 71,633, and I'm going to round to money, 91 cents. Okay, quarterly means that we're going to compound it 4 times, so n is equal to 4. So we're going to have A is equal to 40,000 times 1 plus 0.06 divided by 4 to the 4 times 10. Okay, so let me type that in the calculator. 40,000 times 1 plus 0.06 over 4 to the 10 times 4. And for this one, we're going to get $72,000, 560 and 64 cents if we round. Monthly, that's going to be 12. Okay, for our N. So we have A equals 40,000 times 1 plus 0.06 divided by 12 to the 12 times 10. Let me type that in carefully. And for that one, I'm going to get $72,775.87. If we're compounding daily, that's going to be n is equal to 365. So our a is going to be 40,000 times 1 plus 0.06 divided by 365 to the 10 times 365. So that's compounding quite a bit. And when I plug that in, I'm going to get $72,881.16. If we're compounding continuously, we're not going to have this n value. We're going to be using a different formula. This is in the book too. Let me write it down here a little bit clearer. So for continue, I'll say continuous compounding. The formula is A equals P E to the RT. Okay, so if we label this, this is still principal. R is still rate. I guess let me rewrite it. This is a little bit easier to read. R is still rate. T is still time. And E is just a number. Okay, it's on your calculator, but it's just a number. All right, so when we plug that in for the table, we're going to have A is equal to, the principal is still 40,000. And then instead of plugging it in to that formula, we're going to use E to the RT. So R is still 0.06, and then T is 10 years. So if we're compounding continually, we have 40,000 times E to the rate 0.06 times years, which would be 10. So for that one, we're going to get $72,884.75.